The functions of a heating, ventilation and air conditioning plant can be accomplished by means of different configurations and components, which can be generally organized in four main subsystems. The generation subsystem, which generates or subtracts thermal energy. The distribution subsystem, which transfers the thermal energy to the thermal zones of the building by means of a heat transfer fluid. Emitting units, which exchange thermal energy within the thermal zone. The control subsystem, which controls the operation of the other subsystem. In this lecture, we will analyze the distribution and emission subsystems. HVAC systems are categorized according to the type of fluid used for the distribution, as follows. All air systems, they provide HVAC using only air. The airflow provides both ventilation and cooling. All water systems, only water is used. Cold water is distributed to the terminals and ventilation must be supplied separately. Direct refrigerant system. Instead of water, a refrigerant fluid is distributed to the terminals. Ventilation must be supplied separately. Combined systems. They are a combination of two or more of the above-mentioned categories. The most common are the air-water systems, where sensible cooling is usually managed by the hydronic system, while air provides humidity control and ventilation. In hydronic systems, water is used to transfer thermal energy. Pipes and pumps must be provided to distribute cooled water from the generator to the terminal units. The basic configuration is a two-pipe system, a main flow pipe in which water flows from the generator to the terminal units and a return pipe. Water pipes in distribution subsystem must be insulated to minimize thermal losses and avoid condensation. The main advantage of hydronic configuration is that piping requires very little space compared to air ducts, and the amount of energy needed by pumps is small in comparison with fans. Moreover, if the water distribution subsystem is well designed, it can be absolutely noiseless. In water-based systems, several terminal units can be used: fan coils, active and passive chilled beams, and radiant ceilings. The fan coil is a terminal unit with a cooling coil, a circulation fan and a filter. When hot and humid air circulates through the cooling coil, there is a condensation of the water vapor, which must be collected in a tray and drained away. Fan coil system provides some air dehumidification, which is a secondary effect of the cooling and typically cannot be controlled independently. Fan coil units can be installed in suspended ceilings or along walls. Individual fan coils are connected to the water distribution system, and the control of the unit is achieved either by changing the water flow and/or the fan speed. As opposed to fan coils, induction terminal units have no fans. Air movement in the terminal unit is induced by high-pressure air, called primary air, that comes from a central air-handling unit. The primary air is passed through an array of nozzles in the terminal unit that create a Venturi effect, or vacuum. Similarly, chill beams is a type of terminal unit where water pipes are passed through a beam, which is a heat exchanger, suspended close to the ceiling or integrated into a full ceiling of a room. As the beam chills the air around it, the air becomes denser and falls to the floor, causing a constant convection flow and cooling the room. In passive systems, cold beams can work simply by convection, or in active systems as the induction units, where they are coupled with ventilation system. Another kind of water-based terminal unit is represented by radiant ceilings. They consist of panels with embedded pipes. Pipes can be either embedded in customized construction elements or in precast construction components, such as false ceilings. This type of cooling system is virtually maintenance-free and allows energy saving because water temperature is higher than in fan coil systems, with reduced losses in the distribution subsystem and higher efficiency in generation. Radiant ceilings, by performing the cooling effect mainly through radiation, can provide a good comfort level at higher internal air temperatures, lowering the mean radiant temperature, thus enabling a more efficient operation. However, a disadvantage is that accurate humidity control is required to avoid condensation. As mentioned before, in air systems, air is ducted into the different thermal zones of the building to transfer thermal energy and/or to provide ventilation. In general, different design schemes can be adopted for high distribution systems. The most common are single duct, multi-zone, dual duct and VAV, which is variable air volume. In single duct system, the humidified air at an appropriate temperature is circulated through the building in a single branching duct, but temperature and/or humidity cannot be independently controlled. For this reason, this system is appropriate for small buildings. Multi-zone air configurations are instead composed of an individual supply air duct for each thermal zone in the building. Cool and warm air are mixed to suit the needs of each zone. Once mixed, air is supplied through separate ducts to each zone. In dual duct systems, a central unit provides two conditioned air streams, a cold deck and a hot deck. These air streams are distributed in the building by separate and parallel ducts. A mixing box is provided for each zone. Under the control of a zone thermostat, the air streams are mixed in the terminal box to provide supply air at the required temperature and humidity condition in each zone. Both single and dual duct configurations can be operated either with constant air volume or with variable air volume. In this second case, the airflow supplied to a space is proportional to the changing load. A single central unit supplies air through a common duct to all conditioned spaces, and each zone is provided with a VAV box that adjusts the volume of supply in response to the zone requirements. Air handling units are technical systems containing several components necessary for the operation of an air-based HVAC system. In particular, they are used to perform air handling processes such as heating, cooling, dehumidification, humidification, and heat recovery. They can be either centralized, thus serving the whole air distribution subsystem, or decentralized, which means that they are subdivided into multiple units nearby the different building zones and connected to them. To increase energy efficiency, an energy recovery unit can be added to the air handling unit. It is a type of mechanical equipment that allows a sensible and/or latent heat recovery from the exhaust airflow, for example using a vapor compression cycle. In air systems, air is typically supplied to zones through ducts that terminate with different types of registers, grills or diffusers. Such air terminal units can be placed in different parts of the room. The position of supply air outlets affects the comfort level for occupants. It has to ensure that the airstream circulates homogeneously in each space without striking people directly. Inlet and outlet air terminals should also be placed taking into account the most economic and easiest routes for ducts. The most common are grills, which are opening with several slits in a wall or metal sheet. Registers, which are grills with a damper that allows controlling, directing or diffusing the amount of air, and diffusers, which are devices designed to introduce supply air into a space with a good mixing with the room air. Finally, direct refrigerant, called also direct expansion system, are characterized by the absence of water pipes and/or of air ducts to transfer heat in the building. In such systems, a refrigerant gas is used as a heat transfer medium between the outdoor part of the system and the internal spaces. For this reason, these are called split systems. Such solutions are usually suitable for small or medium-sized buildings, or for this context in which it is difficult to install ducts or pipes, for example, historical buildings. A multi-split system is generally composed of an exterior unit consisting of compressor and condenser elements and an interior unit consisting of evaporator and expansion valve elements. The two parts of the system are connected by a refrigerant distribution pipe. In conclusion, all air systems can provide both heating, cooling and mechanical ventilation, but the air ducts are bulky and could be noisy. All water and direct refrigerant systems have compact distribution pipes, but can provide just heating and/or cooling. Combined systems, such as radiant sealing and primary air, typically ensures the best compromise in terms of energy performances and comfort levels.